Okay, guys, you just got done taking the M4 target quiz, and hopefully you guys did okay on that. If not, there's definitely some studying that you can do for this. Um, but really, it just builds on the last one that we were talking about with the density. And so, if you're still having a hard time with density at this point, you have really got to do some extra studying and try and figure out uh, how you're going to learn density at this point. So, first of all, when we're going to go over this just one more time, the density always equals mass divided by volume. Okay? And so this whole entire unit that we're talking about has to do with this part right here. You guys can pretty much think that mass is going to be constant through this whole entire testing process on this unit. We're only going to be looking at volume and how volume is going to change with temperature. Okay, so we've done this before, but if you don't get it at this point, then we need to just kind of go over it. So, as temperature goes up, volume is going to go up as well. Alright? Now, when temperature goes down, volume is also going to go down. So whenever you change temperature, volume is going to change in the exact same way. Now, here's the thing that you guys get confused on a lot, is that when we're talking about density, that changes. And this should make sense by now. So let's say that we have a mass of 1 grams and we have a starting volume of 1 milliliter. Okay? So, if we figure out the density, that's just 1 divided by 1, which equals 1. That shouldn't be hard. You guys should be able to do that. Now, let's say that we increase the temperature. What also is going to increase? The volume. So, let's say that we have 1 for our mass still, but our volume, let's say our volume doubles on us. Now our density is 1/2 where it used to be 1. So, when temperature goes up, volume goes up, density goes down. Alright, now the opposite is true when we go the other way. So, let's say that we still have the same density, however, when it goes this way, let's say that it goes to 0.5 when we cool it way down, so that is going to mean that our density equals 2 in this case. So it's gotten bigger than when we started with this 1. So again, as temperature goes down, volume goes down, density goes up. Okay, so if you didn't understand that, I would listen to it again, and hopefully it will start to stick and make sense. However, if you haven't gone home and you're having troubles, and you still haven't gone home and memorized this right here, then you need to go home and you need to memorize that immediately. Okay? Same thing with this. If you don't have this memorized by now, then you need to spend some time and really start practicing that and knowing that density equals mass divided by volume all the time. Okay, moving on. Now, over here on this picture, what we've got is, this is a solid, and this is a liquid, and then this is showing us a gas over here. Okay, so, over here with the solid, at first, as you guys can see, everything is really tightly in place, and you'll see right here these little tiny lines right here. What that's saying is that those are wiggling in place and kind of just having a good time. Now, over here, this is when we've heated this solid up, okay? And now it's showing you a whole bunch of extra lines. Well, what that's saying is that when you heat up a solid, that those molecules spread apart because they're wiggling just a little bit harder, and they increase their volume, okay? So, this, where it's cold, has a smaller space that it takes up than when it is hot, okay? So again, what we're talking about is when something is cold, its volume is smaller. When its volume is hot, its volume is bigger. And then, on the same instance, when it's cold, its density goes up. And when it is hot, its density goes down. Okay, now with a liquid. Alright, now as you can see, the liquid's a little bit different. Like, things aren't uniformly packed inside there. It is a little bit of where everything is just sliding past each other. So in a cold environment in a liquid, they're all nice and cozied up to each other, and things are looking good. But then as you get it hot, again, things start to spread out, and they're sliding past each other, but it's way more spread out. So again, this is what you guys have to understand, is that when something is cold, it is more compact. That means it has less volume. If it has less volume, it has a higher density. Just like this, where it's hot, temperature goes up, volume goes up, and density goes down. And then with the gas, we can see kind of an instance here of where we have our initial balloon right here holding a certain amount of gas. If we heat it up, then we see that the volume of our balloon increases. If we decide to cool down our balloon, the volume of our balloon decreases. So guys, you have to get this down, and you have to be able to see what is happening in these kinds of situations. Okay, for the last part of this review, what I want you guys to do is I want you to take a look at this, and I want you to just kind of see how this is going on. Now here we have two different kinds of thermometers, things that measure change in temperature, and both of these different things work on the exact principle that we're talking about. So, number one, in here, we have the old school mercury thermometer. Okay? Now, what happens with this is that when you're in colder air, the volume of that mercury goes down. And so that means that this little line right here, if it's not taking up so much volume, it's going to go further down this tube and kind of shrink away. And that tells you that, and then there's just little markers telling you, oh, that means that it's a colder temperature. However, if things get hotter, then the volume of that liquid increases, and then that shoves the liquid up through this little tube, and as that increases, then it shows that it's a higher temperature. Okay? So even though this thing right here measures temperature, really what it's doing is it's reacting to the change in volume due to the temperature change. Now, you guys have very different thermostats than I did when I was a little kid. Now yours is probably completely digital and electronic, or maybe you even have a Nest and stuff at your house. However, when I was really little, I remember that this is the kind of thermostat that I had. Now, you had a dial that you could change the temperature and stuff like that. And what that would do is that would move this coil back here. And this coil was made out of metal. It was just a big metal spring back there. And then attached to that metal spring was this glass vial of mercury. And so what would happen is that you would change it, and if it was too cold where it would just flip down, and all the mercury would rush down to this side with a sensor, and it would turn on the heater. Well, as it started to heat up, this coil would then expand, and as it expanded, this mercury vial would start to move up this way. And once it moved up far enough, that pressure wasn't on the sensor anymore, and then that told your heater it didn't have to keep on heating at that point, and it would stop. But then when it got cold, the metal would shrink again, and this would go back down, and it would eventually hit that sensor again and warm up. So this is another example of basically it told you the temperature, but at the same time it was telling you that temperature by the reaction taking place from this coil right here. Changing temperature would change its volume. So, guys, make sure that you look at some of these scenarios. Make sure that you understand that as temperature goes up, volume goes up, density goes down. And then, when temperature goes down, volume goes down, density goes up. Guys, please study, do well, and I hope that you guys have an awesome Christmas. Make sure that you are ready on Wednesday or Thursday to be able to take this test and do really, really well. Alright, good luck, guys.